Okay, a simple harmonic oscillator has an equation of position in meters of x equals 7.2 sine 5.1t. So this is in the genre of we've got to use that formula to find things out about this oscillator, right? So the general form of the position is x naught sine omega t, right? This formula is 7.2 sine 5.1 t. Okay, so what that means is that x naught is 7.2 and that omega is 5.1. This must be radians per second, right? And it says it's in meters, so there it is, right? Okay, so now we can go on and do all sorts of stuff here. So what is its maximum velocity? Well, let's solve for the maximum velocity. The easiest way to do this is to look at this formula. V is omega x naught cos omega t, right? This coefficient in front of the cos, that is the maximum velocity. If we called it v naught, like maximum position is x naught, right? That is, so we can just do that, right? The other way to do it is you can use this formula. V is omega square root of x naught squared. And then the maximum velocity occurs when x is 0, right? Well, doesn't that just become omega x naught? I don't know, there's lots of ways. It's not in the data packet, so you got to memorize that the maximum velocity is omega x naught, right? And then once you know that, then of course our maximum velocity is omega, so 5.1 times x naught, which is 7.2, right? So let's figure that out. 5.1 times 36.72. Right, so there's our maximum velocity, right? And then it says, what is its acceleration when it is at 4.2 meters? So it could go all the way out to 7.2 meters, but here it's at 4.2 meters, right? So I'm going to use A is opposite of omega squared x, right? So A is the opposite of 5.1 squared times x is 4.2. So this will be a negative number, right? It's a 4.2 means it's what, above? It's above here. 4.2, it's like there or something like that. And it's definitely accelerating down toward negative, right? Okay, so the opposite of 5.1 squared times 4.2. It's going to be a big number, 109.242. Negative 109.242 meters per second squared. There we go. All right. Snip, snap, snout, this tale's told out.